So now I'm going to emulate Brian and admit the anxiety and fear that grasp me as the next to last speaker of the day, and I wish to summon my mental reassurance that I know what needs to happen. Okay, that put me in the right frame of mind. Okay, so what we need to do, or what I'm going to do today, is I'm going to describe to you something that's perhaps a bit more basic than many of the replication studies going across all these things. I'm going to focus on the use of reproducibility, basically reanalyzing the same data that the people started with to see what can we learn about the results they obtained, and in the process to potentially identify and correct mistakes, and try to discuss when this is of value to us. And this is motivated to a certain extent by an amount of paranoia that I have. And the paranoia that I have is, what do we do if mistakes have actually made it past the literature or are close to doing so? What if we are about to tell a woman that she needs to have her ovaries removed on the basis of a study where all the results are based on complete confounding of the experimental design? What if we're about to enroll cancer patients in clinical trials where the labels for sensitive and resistant in building our model were reversed? Those would not be good things. Those have happened. So can we check things to reassure ourselves that, particularly in instances where the results are likely to affect patients or public health, that we know precisely what was done? Occasionally, this may lead to questions, and this may lead to challenges. And for example, what happens if a challenge comes up where we find ourselves forced to question, say, a reference coming from a National Academies report? And I'm going to tell you about an ongoing example. This is not fully resolved. And I'm going to, well, let's see, is Kathleen in the audience? I'm going to credit the origin of my inspiration for this particular topic, see? That's the positive COI, which is I've got to acknowledge that this study is about nutrition, not genomics, and my mom drew this particular issue to my attention, and she said, I don't understand this, could you look at it? And I said, sure, I'll help Mom. And I started looking at it, and I said, oh damn, the data's wrong. And in particular, what I am seeing is that looking at the current US recommended daily intake for vitamin D, which was set in 2011, I believe that value is too low by a factor of at least 2 and more likely 5, at least in part to basic math errors. This could be a problem. So given that we suspect this, can we confirm this? Can we look at fixing it? And part of what I'm going to do today is I'm going to walk you through this exploration, trying to address this. And to begin with, I need to give you some context. I need to tell you, when we come up with these things, where do recommendations come from? How do we make these things in the first place? And basically what happens in coming up with dietary recommendations is that the Institute of Medicine, now the National Academies of Medicine, will often convene a panel of experts, and they will charge this panel of experts with doing a few things. Specifically, they should look at the literature on that vitamin or that intake, and they should say, wow, as we look at this, what clinical outcomes are associated with consumption of that vitamin? Incomes, outcomes, whatever. And there may be several. So for example, in the context of vitamin D, we know that complete absence will cause rickets, soft bones, children with bow legs, etc. There are others, which is that if you have elevated, not quite high enough levels, then as you get older, you may develop osteoporosis, osteomalacia, things like that. But in that case, those two clinical outcomes, one dominates the other. If you've got enough to protect against osteoporosis, you've certainly protected against rickets. But by looking at the literature, we identify for what outcomes the literature base is strong enough to guide an actual recommendation. And in this particular case, the committee, reviewing the evidence, 1,000 or so papers, decided that there was really one for which they were confident in the evidence base, and that was bone health. Guess what? Vitamin D affects that. Okay, big surprise. But having decided on this outcome, the next thing that they have to decide is, based on data in the literature, can they estimate the distribution of intake requirements for the population? How much supplement, if as given to you, or you, or you, or you, overall would result in most of the population being healthy? And most of the population, by their definition, is 97.5%, because it's a bell curve and it's 2 standard deviations up, and it's a magic number, which is wonderful. So given that as a set of goals, and there's another set of goals associated with not going way, way, way too high, but we're not going to worry too much about that now. The way that they're going to distill that is they're actually going to try to boil down a very small set of numbers known as dietary reference intakes. And you've probably heard of a few of these. The very first one, and the most important one for us, is the recommended dietary allowance. That's how much you should take to remain healthy as an adult. And, okay, and in order to estimate this, well, again, since we're assuming the magic of normality, one of the ways that we often get there is to identify the average intake requirement, the mean, estimate the standard deviation, find the recommended amount. Great, okay. Taking data, estimating mean, standard deviation, I'm a statistician, I'm feeling comfortable now, this is home territory. Okay, so I think I understand that, but there's this issue of this phrasing, nutrient requirement. Okay, so I got to keep this in mind. If I am meeting requirements, in other words, if I am giving you enough intake, and this is measured in terms of international units, then if you have met your requirement, that basically means that you will not develop osteoporosis. That's how it translates. Now, the particular recommendation, just as a matter of scale, currently is 600 international units a day. So that's the point of calibration. Now, given that we've looked at these reference intakes, and given that we want to define requirements, things that people will need, okay, we know how to do that, but there's just one technical issue, which is that most often it's not that easy to define requirements, biochemical outcomes, in terms of intakes in international units. The way it works typically is that you give, or you take measurements of biochemical analytes, and in particular serum levels of 25 OHD. That's what the intake gets converted to. And you see, is there enough 25 OHD in the serum that all biochemical processes are not hitting rate limits, that they run to their full completion. So we can estimate how much a given person needs based on their serum levels, but in terms of telling them how they should behave in real life, we've got to tell them how much intake to consume. So we're actually working in 2 different sets of units, serum levels and intakes. Now, why does this matter? Well, pretty much because in order to map from one to the other, we've got to estimate a dose-response curve. Okay, that's a straightforward mapping. But there's another issue, which is that we know for a given bell-shaped distribution, like the distribution of requirements, there's variation in requirements. But also, if we think about fitting another source, another issue, there is also variation in attainments, which is that if I give Victoria 2,000 international units, she might reach a serum level of 25 nanograms per milliliter. If I give Regina that same amount, she might reach 30. So there's variation in attainments and there's variation in requirements. And we've actually got to model both of them. Now, for several vitamins, that variation in attainments, how well our bodies convert what we chew or swallow or whatever to the amount that's processed in our blood, the conversion rate's probably pretty high. That's because we've evolved to efficiently grab those trace elements from our food. That's not a safe assumption for vitamin D, because guess what? We evolved to get most of that not from what we eat, but from going outside. So we potentially have to keep this in mind and model it both ways. Now, just to give us an idea of how this mapping back and forth might work, here is a dose-response curve, mapping, in this case, intake on the x-axis to serum level on the y. You'll see it's actually a nonlinear curve. And part of the question is about that variation in intakes. One of the questions is, are the various study means close to, in vertical lines, this fitted curve. And they're actually not that close, so there is a sizable amount of variation in attainments that we also have to model. So from a mathematical standpoint, how do we do this? Well, actually, the way we do this is we draw pictures, and we do two things. We basically say, in the formal math geek phrasing, so all the statisticians get to look at this bit and they say, yeah, that makes sense. For everybody who's not a statistician, basically, here's what I'm going to do. I'm going to say, for a given person in the audience, Giovanni, congratulations. I'm going to pick at random your serum level requirement. Let's say it's 5. And then I'm also going to pick at random the serum level you attained for the dose that we gave you. Here it is. I look at the cross point. Congratulations, the level you attained is above the level you required. Your requirements are met. Now I'm going to do the same thing with Regina. I'm going to randomly select here, where your requirements met. Congratulations, they were. Victoria, sorry, you get to, for the purposes of illustration, you didn't have some. I'll give you some more later. But basically, if you do that over and over again, you can estimate by moving this ellipse up and down, changing the intake level, you can find the intake where the chance of having our requirements met is exactly 97.5%. That's what the RDA should be, okay? So that's the goal. That's the health goal. That's what we're trying to do. Now, given that, there's the question of what was actually done. So now let's shift to looking at things in the report, because what we need to do, or we need to do three things. We need to estimate cut points in terms of serum levels. We need to fit a dose response curve relating serum levels to intake, and we need to account for variation in intakes. 1, 2, 3. So the first thing is defining cut points in terms of serum levels. So how'd they do this? Well, in this case, the IOM committee took advantage of a very recent publication by Primo et al., and this publication was very important for them because they did something really hard in this publication. Specifically, what they did is they said, we want to measure bone health. Most studies do this indirectly. You measure serum and you can do that. They don't do it directly. They don't measure bone because, quite frankly, sampling bone hurts. Most people do not want to give bone samples. So how did these guys, Michael Primo and Michael Amling's group in Hamburg, address this? They got slightly ghoulish and they went to the local morgue and they said, we're going to collect fresh autopsy specimens from car accidents and the like, and we're going to collect bone from the iliac crest to the pelvis where new bone develops, and we're going to take blood samples because 25-OHD doesn't degrade that fast, and we're going to correlate the serum level to the amount of newly formed bone, which we sample here, which hasn't mineralized, become hard and strong yet. So we want that rate of unmineralized bone to be low. But the thing is, they did this for 675 patients, and they were able to relate levels of strong bone to serum level. And in particular, there's two units of measure that are commonly used for serum level in vitamin D. There's either nanograms per milliliter or nanomoles per liter. The scaling factor is 2.5. Sorry that there's two types of units. I didn't choose it. But Primo et al. Said, you know what? If you choose a cutoff, a serum level, for a targeting for the population of 30 nanograms per milliliter, pretty much everybody above here has a small turnover fraction, but not very high. They have strong bones. So that's what we recommend. And the IOM committee looked at this report, looked at this data, and said, we're going to come up with our recommendation. So what is their recommendation for the serum level we should be targeting? It's 20. It's not 30. Okay, why is it 20 and not 30? Well, because they looked at that plot and they said, well, if you're at 30, everybody's healthy. And that's too good. We only want 97.5% to be healthy. And okay, fine. But all right, let's say that you don't want to worry too much about that last tail, but let's say that you do want to estimate precisely where 97.5% happens. So how did they do that? Well, let's read this, because this is actually sort of important. So we looked by eye, and at a 25-OH level of 50 nanomoles, there were 7 data points, people with problems, levels of soft bone ratio above 2% on that plot. And if we take that number, 7, and we divide by 675, well, that's only 1%, so we're in good shape. But what'd they just do? I want to draw a picture. They took all the points in this pink region and they divided them by all the points on this plot. And what they're trying to do is they're trying to estimate the ratio of pink plots or pink dots in a very narrow vertical region of this plot. So guess what? This is wrong. So they've chosen to set the limit or the cut point at 20 nanograms per milliliter based on this mathematical rule. What happens or what result do we get if we zoom in just on 20 nanograms per milliliter? Well, here's what I get. Counting the points really close, 13 have problems, 22 don't have problems. Overall rate of problems is 37% at a level where they're saying we should only have 2.5% with problems. That's probably bad. Now, can we find what it should be? Well, what are we trying to do? We're trying to find where a proportion, a fraction of people with soft bones, gets really low as a function of serum level. Well, guess what? Fitting proportions as a function of a variable, statisticians probably know where I'm going with this. Most of you have heard of the phrase logistic regression. So if we fit a logistic regression curve to this data, we find that oddly enough, the recommended daily allowance should be or the serum target level should be actually a bit above 30 nanograms per milliliter, not 20. We're off by a bit over 50%. Now, the mapping from the serum requirement to intakes is nonlinear. So what that means is that a 50% jump on this scale is more than a twofold jump on the intake scale. That's the source of that lower bound where I said we're at least twofold too low. It's this mistake. Now, given this, this tells us where they found the upper cut point. Well, most often, people would start by estimating the mean of a distribution and adding the standard deviations. So did they look at the central point, the average point, and then give themselves a calibration point to allow themselves a chance to catch this problem? Well, actually, no. In this particular case, they said, well, most of the time we would do that, but here we're really confident in our ability to estimate the upper tail far better. So we started at that upper tail and we moved down. They moved down, and to move down they assumed a 10% coefficient of variation. I'm not sure what data they're basing this on. This is a standard assumption for most vitamins, but it's not necessarily safe for vitamin D. Now, this causes a problem, but perhaps more troubling to me is that this problem, dividing by the wrong number, was actually first noted in 2011 when the report was issued. And it was covered at the time in a full news feature in Nature, where Amy Maxman talked with the authors of the report, she talked with various others, and in particular, members of the committee responded to this issue that you've divided by the wrong number and told them, well, the method that we use to calculate 1% risk is standard procedure for dietary recommendations. I sincerely hope this is not the case. But that means that we may have a problem, and we're probably going to have to go back and fix it, and it's been a few years. Now, that's one part of the modeling process. We've estimated where the cut points are in terms of serum units. The next thing we have to do is we have to map serum to intakes. So how did they do it? Well, the way that they do it is they looked at a number of published studies where there were randomized clinical trials saying, we'll give you this much vitamin D, and then we'll come back and we'll measure your serum levels a bit later. These were 10 randomized clinical trials after their filtrations of a much larger number. That was all they came down with. These are 10 randomized clinical trials where all of these studies were conducted at latitudes above 50 degrees so that they didn't have to deal with that pesky sunlight issue. And there were some studies that involved kids, some that involved adults, some that involved older ones, and they fit each subgroup separately, and then they fitted them all at once. So, okay, they're going to do this. How did they fit the curves? Well, they said, we're going to take the following data. We're going to collect for each sample in each arm the number of patients. We're going to collect the average total intake, the serum level. We're going to record the standard deviation. This is a standard deviation in attainments. We're not going to bother using it, but we're going to record it. And then when we choose to fit the model, we're going to do a regression analysis using a mixed effect model. And by the way, as we fit our mixed effect model, we're going to do regression where we set the intercept to 0 because that's the biological reality. The biological reality, this is a bit weird because it assumes that their mathematical model is actually real as opposed to an approximation to the truth. But that's what they've done. And well, this is a challenge. So they've given me the data. I typed in the table by hand. I can fit this curve. I can fit the curve for all the data points. I can see what they come up with. And guess what? Here's that curve. And if you look at that curve, that black line is what I get now, the red dashed lines. The central one is what they said they got. And these, they say, are the bounds that are relevant. Problem is that when I fit this, the black dashed lines are the ones that I think are relevant. So they're a bit too narrow. And what's going on is, at least in part, they are, I believe, ignoring the variation in attainments completely. This is the distinction, in statistics speak, between using a confidence interval for the mean and a prediction interval for who's going to actually benefit. Now, they did tell us that they fit separate ones for each of the submodels, so maybe we can look at those individual submodels and be sure that this is what they did. Well, we tried that, but unfortunately that didn't work because the number of standard deviations was different for every single submodel they fit, so we're not completely sure what they did. But there's also the problem that the original code is no longer available, so we don't know. Now, we could potentially fit related models using JAGs and various other things, but at the moment, we've got a general curve, we know roughly what's going on, and we see that there's a problem. Now, there's also the issue of, well, how big is that problem? I've said that they're ignoring that variation in attainments. How big is that? Well, relative to what? First off, we know, because they told us, we started with an upper limit here, and we went to an average here. This was 50 nanomoles, this is 40, that's 2 standard deviations. That means that in our estimation, the standard deviation of requirements, the thing that we're trying to measure, is 5 nanomoles per liter. How big is the variation in attainments relative to that? Well, they recorded the standard deviation for the various studies they used. And for the various studies, some of the studies didn't record this information, so we don't have it. But for this study, for most of these studies, it's about 4 times as big. This one, which looks really low, it turns out that because plotting these looked really weird, we went back and looked at this paper. In this case, they'd actually recorded the standard error of the mean, not the standard deviation, so those values are actually up here. But basically what's going on is that you've got 2 sources of variation. You've got a source of variation due to requirements, source of variation due to attainments. This one is bigger by a factor of 4, and this is the piece that's being ignored. That's a problem. Now, we've noticed this. As it turns out, we weren't the only ones to notice this. There was a paper by a group up in Canada, Paul Voigelers and John Akwaru, who looked at this data and said, wait a minute, guys, if we take your studies and we subtract 2 standard deviations and we look at where the means are, they come down on a curve way down here. Maybe you just fit the standard error of the mean instead of a prediction interval. And so they said, this is bad. Now, they also gave their interpretation of what this would mean. And this caused a problem because they said, if we do this, then the biological goal, the public health goal, will not be met because in various studies, you will have less than 97.5% of the population having serum levels reach 20 nanograms per milliliter. The problem is the public health goal is to have requirements met. It is not to get people to a specific serum level. And if it is to get people to a specific serum level, it's probably not to the upper tail of the serum levels. So they have misstated the public health goal, but their intuition that we're ignoring a lot of variation and we should deal with it, that's correct. But in this case, because they knew a particular businessman in Canada who got rather incensed about this, he ran half-page ads in the Globe and Mail saying, guys, this is wrong. So the IOM looked at it, and the IOM's response was, guess what? You got the terminology wrong. The goal is not and should not be to get our serum levels or get everybody up to the serum level. They addressed the imprecision in the wording. They missed the spirit of the objection. So that's a bit of a problem. So I've just told you that I don't think so I think they've missed that, and I think their RDA is too low. So there's a question of, well, what do I think should be the RDA in terms of an intake? I've told you what the serum level should be. I think it's about 30. Well, how can we do that? Well, the first thing we need to do is we need to say, do we have data where we can say, for a given intake, what their serum level will be? In this case, I went ahead and said, I know of an observational study where I can get access to the individual patient level data. So I said, let's grab that, because I don't really believe that these distributions are normal. So I'm going to grab that, and I'm going to say, for every one of these where I've got a large number of observations, I'm just going to sample one of these values at random as the distribution. So that deals with the variation in attainments. And in terms of the variation in requirements, well, it turns out that somebody else, Alicia Colloquia and folks, estimated the requirement levels by serum, and they actually came up with an upper serum level about 28. So here's the distribution. And what we can do is by combining these two, we can produce our estimate. And if you actually plot the intakes that will reach requirements being met, you hit 97.5% at about 3,000 IU a day. The recommendation is 600. That's why I'm saying it's probably 5 times too low. I am not claiming, by the way, that this is the absolute best analysis. If somebody comes in and starts futzing with it and finds that 4.8 is probably good, I'll give them that. I'm not going to worry about it. But the thing is, this is a lot bigger than what we're currently doing. So that becomes the nature of what do we do now? So now I'm going to shift away from the science because, well, we know that there's a mistake. I'm pretty darn sure it's a mistake. I've documented it, I've done the code, I've looked over it. So now there's a question of what do we do about it? And this actually gets to be something of a practical point. So to David's point, I actually know of a few more mistaken papers in the literature. I haven't really tried to pursue all of them because for some of them, it doesn't matter that much. Here, this may affect patient health for the US and Canada. So that's probably worth doing it. And also, in order to fix it, not merely write an objection, but to try to actually get the recommendation changed, that's going to be a different level of investment of effort. Can we do that? Are we prepared to do that? Are we positioned to raise the issue? Fortunately for me, I'm a tenured full professor. So I have some level of security here. If it were a grad student who'd noticed this, I would strongly advise you team up with somebody tenured, at least to give you some cover, because believe it or not, saying that there's a major mistake may possibly piss some people off. Just a thought. But having identified that we want to fix this, there's the additional question of, do we know who to talk with? And in particular, if it were in a journal, I'd go to the editor. The authors, well, the authors have already in print, dismissed the 2 major concerns I have, so I'm not that optimistic there. So I don't know really what to do. So actually, I tried something different, which is basically I started yelling at everybody and saying, who can help me? So starting late last year, I went around and as I was giving talks on related topics, related to reproducibility, I would toss some of this in here. And I would say, does anybody have an idea who I should contact? And over dinner, after one such talk, Giovanni Parmigiani said, you know what, you should talk with Konstantin Gatsonis, who's the chair of the Committee on Applied and Theoretical Statistics. So I sent Konstantin email, and he said, that's really interesting. You should probably talk with the Report Review Committee. That's normally headed by Stephen Feinberg. Stephen Feinberg wasn't feeling that well, so amongst other things, it got redirected to Porter Coggeshall. So Porter, here in the audience, is an employee here at the National Academies, and congratulations, Porter then got slammed with a whole bunch of slides and reports and various other things from me saying, I think there's a problem. And he looked at them and said, this looks potentially serious. I need some help. And he said, I'm going to recruit a statistician who has exposure to nutrition. So he went off and found Alicia Colloquia, who agreed to look at this. And they said, okay, we'll talk with you. Now, so we found who to talk with. So the next part is just basically talking with them. So sent the whole bunch of reports. Alicia skimmed them, talked with them on the phone, got some reports back from Alicia. Alicia pointed out that in my first communication, I was misusing some terminology. So I didn't have things phrased precisely correctly, which led me to go back and say, okay, can you give me the references to tell me the terminology? So now I'm using things like attainments and requirements more precisely. So the first part of the talk is now correct, but it wasn't the first times I gave it. But the other thing that I told them was, you know what? Okay, I understand that I may not be using the terminology precisely right now, but I'm still sure there's a mistake. Are you willing to keep talking with me? just to make sure, just to raise my comfort level. And they said, okay, we're pretty convinced you're not a kook, so we'll at least keep talking with you to see if we can get this resolved. And as we kept talking, we fairly quickly divided two issues that I presented. The first is this issue of the math error, what the heck did they divide by? And the second is, how did you deal with modeling variation in attainments? And this division turned out to be rather important because we could look at them separately, and actually Leisha went back and said, was there a math error? Well, let's check the RDA another way. So she went back and she looked at another biochemical outcome for bone health, which is parathyroid hormone data, completely different samples, and in her models of that completely different set of data, she comes up with an estimate of about 28 nanograms per milliliter, far closer to 30 than to 20. So completely different data is telling us that it's 30, not 20. So we have, at this point, agreement that there is a major mistake. There may be two, but actually that's not required. If we're going to say we need to fix something and we need to alert the academies, knowing that there's at least one really big problem is the threshold. So we agreed that there was one really big problem, and Porter said, okay, I want to discuss this with the report review committee, amongst other things, because this may have some bearing on how we address or how we prevent other problems in the future. But the other thing is, because this is a big problem, we need to raise it with the leadership of the national academies so that we can see, can we fix this and how? Now, some challenges to this. Well, Hilda, in her talk yesterday, noted that if you're going to comment and try to get something fixed, it really helps if you do it right away. 5 years is not right away. So actually, in this case, the committee was disbanded, and while the report review committee can handle or can simply deal with small problems really in place, this isn't a small problem. If we are correct, this is a big problem. So there may indeed need to be new discussions for checks and various other types of analyses and how we should revise the process in light of this. So there are challenges, and as we were having these initial discussions, something else happened, which is that the authors of the initial IOM report wrote a perspective piece in the New England Journal saying that, well, people appear to be getting all worried that their vitamin D levels may be too low. This is nonsense. The levels in the US are just fine. There is no problem with them being too low. We wanted to respond, and we did not want to alienate folks that we were trying to work with here at the academies, so gave a heads up to Porter and Alicia, said, this is out there. We're going to respond. We have a month. Can we do anything? And basically at the end of the month, still working on it here, submitted a letter to the New England Journal, and what happened? Letter rejected. I actually have a pretty bad record of getting letters of correction accepted to journals. Whether my points are correct is an entirely different issue, but I can't get the letters into the journals. That's a problem. So, at any rate, move back. So, Report Review Committee has now looked at this. We've been going back and forth. We're still trying to clarify what the RDA should be, but in the meantime, this was discussed at this year's annual meeting of the Report Review Committee, and they are now trying to identify better ways or better institutional processes that they could implement for determining credibility of challenges. When is this really a problem, and how do we respond to them? So that's a process issue that's getting sparked by a mathematical issue. And then there's the issue of what's going to get done. So leadership got in touch with the committee and said, we have a problem, or we may have a problem, and here's what's going on. And the committee first objected to the process. They noted that they had not been contacted directly during this, which is true. We had not gone to them first because we thought the issues had already been seen by those, and also, believe it or not, that New England Journal letter, it was forwarded to the authors for comment if they chose to make one, which they did not. So they requested more time to review the issue, and to help them, we actually wrote up a detailed summary of the mathematical error. We wrote it all out, 9 pages with lots of pictures saying this is what we think is a problem. And the leadership pressed the committee saying, this is a pretty blunt issue. There appears to be a math error or there's not, and it may have a big effect or it does not. We would like to know fairly quickly if you can tell us what's going on. After about a month, it was decided that this 9-page summary of the math error would be sent to a new group of experts for review to see, did the new group of experts agree that there was a problem that would require resetting the RDA? Yes or no? If they think that there's a problem, we'll have another group or we'll then at that point argue a bit more about what it actually should be. But the first question is, does it need to be changed? After this decision was reached, the committee actually submitted a report in writing, and their report is also going to be sent out to the experts for review. The high points of that response are, well, that Baggerly's focus in particular on modeling of data from Primo et al. And so on like that it's not really relevant. The data wasn't that important to their conclusions. He mentions that the RDA was estimated before the EAR. This is not the case. He has misstated our charge. And while the mathematical modeling is appreciated, it's nice to have statisticians involved, it's really insufficient to choose these particular cutoffs. And although I'm sure they didn't mean to, they also introduced in their response a completely new math error showing that they really didn't appreciate where the upper thresholds should be set. So my own reply to this particular one, while they say that Primo et al. Is not relevant, what disturbs me most about their response is what's not there. Their entire response makes no mention of the mathematical error at all. It makes no mention of the fact that there was supporting evidence from parathyroid hormone data. Completely orthogonal thing saying that the numbers are wrong. Why did we focus on Primo et al.? Well, from the report, let's see. We used the work of Primo et al. To set this threshold. They chose the EIR before the RDA. Well, we started at 50 and then estimated this one. We didn't do what they did? Well, okay. I didn't do what they did. They didn't tell me what they did. I don't know how to prove a negative. So this is a problem. So I want to put this in context. US levels in today, these are serum levels, US population from NHANES, right here. These are the committee estimates of where we should be. There's their average level at 40. And they're saying, we don't have a problem because based on our estimates, probably only 15% of the US population is deficient. If we think that the levels really, or the average level really should be over here, only 60% of the US population is deficient. By the way, also late last year, the European Food and Safety Administration adopted 50 nanomoles per liter as the cutoff for vitamin D based on the IOM report. So it may have a bit of broader applicability. Now, is this really where we want to be? Do we have other evidence? Well, it is barely possible that the default US population distribution may not be what is optimal for humans, because, believe it or not, we may not have evolved to spend all day indoors in conferences. Very silly. I know we're getting there. So can we get better data? Well, actually, a group in the Netherlands said, you know what, we're going to go out to East Africa. We're going to take serum samples from a bunch of tribesmen out there, and guess what? If they plot their serum levels, well, this is 50. This is where most adults are in Africa, about twice that high, and okay, 2 to 3 times that high. That's where most adults are. There is one subgroup of adults that's very different, much higher. What is this subgroup? Pregnant women. Guess what? If you're trying to develop the skeleton of a new small being, you need more vitamin D. So that might be relevant. So we actually think the levels should be higher. And as another point of comparison, so we acknowledge that the African levels, there may be real differences between Africa and US. This is not a perfect one-to-one comparison, but it's much higher. And if you look at the serum levels of women in South Carolina today who are pregnant, there's some racial disparities here. Here's the average level for white women. Here's the average level for black women. They're coming in below the IOM's recommended level. They're coming in below this level for pregnant women. So we actually have a suspicion that by raising their vitamin D levels, we may improve birth outcomes. Now, what do we think this would take? Probably about $10 per woman. What's the cost of the standard preterm birth treatment for women at high risk? It's called McCaina. It's about $30,000 for 9 months. So there may be the option for some savings in healthcare there, if this works. Who knows? But that's where we are today. And to sum up my own position, I think the current recommendations are wrong. I can point to a detailed record of data and code and quotes that says why I believe this and where I think the levels should be. I believe the National Academies has been working in good faith to try to address this. I am perfectly okay with sending this out to experts for comment, to get feedback on this, as long as the feedback is fairly quick, and I understand that the goal is to have some feedback, yes or no, by the end of this month. Now, as it happens, it's possible that the experts that they asked to review this may decide that there isn't a problem. Will I stop at that point? Not necessarily, because unless they also supply, along with that decision, code and documentation saying how they came up with that recommendation, I'm going to stick with what I have. I want to be convinced by the data, not by authority. Now, I'm waiting to see what happens next. Fortunately, there are reasons for hope. To quote from a whole bunch of journal editors the other day, I'm an optimist. And one of the things that makes me an optimist is that we were able to look at all this because we were able to access some of the data and code. We'd actually like to see more data and code, and believe it or not, this is National Academies policy now. Actually, it went into effect as National Academies policy in 2012. This report came out in 2011. Whoops. Okay. But it's getting better. Furthermore, how can we do this? How can we do the plots right? Really what we're trying to do in evaluating all this stuff, this is actually by the nature of a systematic review. We have a specific outcome. Can we look at? And if we're doing a systematic review and meta-analyses, guess what? There are guidance documents on the web that actually give good advice. These are live links. By the way, if anyone wants the slides, you're welcome to them. You can click on them. You can follow these things. And oddly enough, we know how to plot the data and see what's going on. Just as a quick sanity check, having at least 2 people check the numbers that you have loaded in by hand from tables is a good idea. There's at least one quote-unquote serum level in that table, which is actually the average age of the study participants and not an actual serum level because they quoted from the wrong table. But that's actually a minor thing. But the takeaway thoughts. So fixing mistakes is not necessarily easy, but it is. So if you decide that it is important, be prepared to persist. Allow for the possibility you might be wrong, and combine them, please, with sanity checks. Having a second source of independent data tell us that we're right, that helps a lot. Please, try to clarify it. Draw pictures. Talk with other people. Say, do you understand me? And if there are many problems, and you're objecting to, and they're all really big, choose the cleanest one that you can explain, and focus on that to start. So, I'd love to see, or some of the questions I'm going to toss to the audience is, how much of this could be mapped in this context where we actually did take a good deal of time and interaction to a journal system, where if there's something where we think it's honest to God important and it might affect patient care, could we get similar interaction from editors at the journal to address this? I don't know. If people want to look at the data, by the way, since this is a conference on reproducible research, if you want to see my documentation, get the code, click on it, go to the links, it will be there. And I do have to do 1 or 2 more things. First off, I have to acknowledge that this is the result of some interactions, particularly in this particular point with Porter Coggeshall and Alicia Karakwiri. The data for that observational study came from Grassroots Health, which is run by a person by the name of Carol Baggerly, otherwise known as Mom. And I do wish to acknowledge others who have contributed to this and to end this conference in a certain extent where we began. One of those would be Steve Feinberg, who set this in motion. And I do have one last group to thank, which is you guys for sticking around through the last full talk of the last day. Thank you.